In this video, we will look at one of the shortcuts to factoring certain types of trinomials called simple trinomials. But before we do that, we're going to do a little warm up with decomposition to make some observations. So you will notice in these two warm up examples, we have trinomials, but what's special about these trinomials is that they both start with an x squared. There is no other number in front of x squared besides the invisible 1. So we will factor this using the decomposition we already know. So if the coefficient is 1, 1 times 15 is 15 for our product, and our sum is positive 8. So our two magic numbers in this scenario will be 5 and 3. Notice that the product is actually just the constant because 1 times anything is itself, and the sum is still that middle term. Now let's decompose the middle term into, I'm going to put 3x and 5x plus 15. And then when we pair up our terms, the first pair just has an x as a common factor, and the second has a positive 5. So when you factor out the x from the first pair, x squared divided by x is x, and 3x divided by x is 3. And the second pair, when we factor out a 5, we're left with 5x divided by 5 is x, and 15 divided by 5 is 3. We know we've done this correctly because the brackets match. So when I pull out that bracket from each unit, you're left with x from the first one and plus 5 from the second. And there we have it. Notice that in both of your brackets, you're starting with x, because the first term is x squared. So if you think about FOIL, when you do your firsts, x times x is x squared. There's no other coefficient that can go in front of it, or else you won't get that x squared at the start. Let's go to the next one. Our product here will just be negative 21 because there's just a 1 to multiply by, and our sum is negative 4. The magic numbers here will be negative 7 and 3. So when we decompose, plus 3x minus 7x minus 21, pair up. From the first pair, again, just an x. From the second pair, we're going to take out a negative 7 because the first term in the pair is negative. When I divide out the x, we're left with x plus 3. When I divide out negative 7, be careful with your signs here, we're left with x positive 3, the brackets match, so x plus 3, and then x subtract 7 for the second one. And again, you will notice that both brackets start with x. Now what I want us to look at carefully are the numbers inside the brackets. You will notice that the numbers inside the brackets match the magic numbers. So these are called simple trinomials because the coefficient in front of x squared is just a 1. When you do your product and sum, once you have your magic numbers, you can actually skip the middle steps of decomposition and go to the very end. Start each bracket with the x, and each bracket will have one of the magic numbers with the correct sign. You can still do decomposition, but it is a little bit more time consuming. So if you can recognize something as a simple trinomial, you are free to do the shortcut. That being said, don't do this shortcut if something is complex. This only works for the simple trinomials. So, how do you recognize a simple trinomial? The coefficient of x squared is 1. So if you look at these examples that we have here, x squared, x squared, x squared, and the last one is not a simple trinomial. However, sometimes there is something you can do to make it simple, and we'll get to that at the end. All right, so we're going to start in the same setup of product and sum, but this time, because there's just a 1 here, 1 times 20 is still 20, so our product is 20, our sum is 9, and in this scenario, the magic numbers are going to be 5 and 4. Instead of doing decomposition, because I recognize this is a simple trinomial, I can do this setup. So I put my equal sign. I have two brackets. Each bracket will begin with x because I know to get x squared, x times x is x squared. And then my numbers were positive 5 and positive 4. And you can always just do a little FOIL in your head to see if it makes sense. X squared plus 4x plus 5x, which is 9x, plus 20. And it's correct. So this is a one-step scenario. Again, only for simple trinomials. So let's look at the next one. We need our product to be negative 24 and our sum to be negative 5. Your magic numbers here, one of them has to be negative, so negative 8 and 3 will work. So you can just write x subtract 8, x plus 3, and that would be it. Of course, you can do decomposition, but it's not efficient. Decomposition will work for everything. This shortcut will not work for everything. I want you to try B on your own, pause the video, then come back to check. So your product should be 10 and your sum should be negative 7. Because the product is positive, both numbers have to be the same sign, and they should both be negative so that they add up to the negative 7. So negative 5 and negative 2, which makes our factored answer x subtract 5 and x subtract 2. And that would be it. Now I said the last one is not simple. Not. But we know that our first step should always be look for a common factor. And if I look at these three terms, they can all be divided by 3. So if I divide out of 3, I'm left with x squared, subtract 8x, plus 12. Now, this is a simple trinomial. In my next step, I will leave the 3 in front and then set up my two brackets. But now I can just find my product and sum. So I need my numbers to multiply to the 12, and the sum is going to be negative 8. So again, they're both going to have to be negative here. So our numbers are negative 6 and negative 2. So we can jump to our brackets. So the 3 is out in front, x minus 6, x minus 2. And there you have it. And there you have it. So for simple trinomials, the coefficient of x squared is 1. You'll set up your product and sum the same way as with decomposition, but instead of taking that decomposing step, you're going to jump to your brackets, start each bracket with the appropriate variable, and add in your magic numbers, 1 in each bracket. And if you're uncertain of your answer, you can always do a quick distributive property on the side to make sure if you were to expand your factored form, you get back to the original expression. And that's it.